Algebraic expressions. To the right over here, we have an equation, we have an expression. Well, which one's which? Well, an equation needs to have an equal sign in it. So the first one is an equation. Equations can actually be solved. However, the one over here on the right does not have an equal sign in it, so it's not an equation, it's only an expression. Expressions cannot be solved because they're not equal to anything. The only thing you can do is just simplify. Here we have an example of a polynomial, which is just several terms added together. Now we have three terms. What's the stuff in between the plus and the minus signs? So this is referred to as our constant because this term never changes based on what x is. Because if x is 7 or if x is 12, it has no effect on this term. It's always 2, so that's your constant. Your variable in this case is just an x. Your coefficients are the numbers in front of your variables, so your coefficients are your 5 and your -7. Our degree is our highest exponent. Your leading coefficient is the coefficient, the number in front of your term with the highest power. This is an x to the first, that's an x cubed, so your leading coefficient is 5. Now once again, polynomials are several terms added together. Could be just one term by itself though. None of the exponents on your variables can be negative or rational, meaning no fractions. So for this first one here, is this first one here a polynomial? The answer would be no, because we have a variable in the denominator. And you don't want to have variables in the denominator. Is our second one here a polynomial? And the answer is no, it is not, because we have a fractional exponent. And your exponent has to be a positive whole number. So as we look here, once again, this one is not a polynomial because we have a root here. Remember, a root's really a fractional exponent, so this is really an x raised to the 2/3. So it's not a polynomial because of the fractional exponent. This last one here is a polynomial because all your exponents on your variables are positive whole numbers. No variables in the denominator, and no roots on our variables. Yes, we do have a root here, but it's only over the 3. Well, now we need to go ahead and simplify. So on this one here, our parentheses at the very beginning are doing nothing, but here we'd actually have to go ahead and distribute through the negative sign. So we're going to just go ahead and drop the parentheses on the first one because they're doing nothing, distribute through on the second one, and now all we're going to do is collect our like terms. Like terms are those that have the same variables with the same exponents. You only have one x cubed, so that goes there. Here you have an x squared term, here you have an x squared term, so you need to combine those together. Here you have an x to the first, here you have an x to the first, you need to combine those together. Then you have your 2 and your -2, your constants, you combine those together. Over here in this one, the first part you're going to have to FOIL, multiply together your first terms, your outer terms, your inner term, and your last terms. Now, over here, I would go ahead and leave the 7u there. FOIL the two parentheses together. First terms, last terms, inner terms, and last terms. And I said last terms here, that's really outer terms. Sorry about that. Collect some like terms. Your u's go together, give you your 5u. Here your u's drop. So we have this. Distribute your 7u through to your parentheses. And then all you have to do is just collect your like terms. You have a u cubed that goes in front. U squared goes here. U to the first, u to the first comes down to give you this. Well, here we have another problem we need to simplify. Once again, these are not equations, so we cannot solve these. We can only simplify these. Well, here you have two terms on top over one term on the bottom. Well, you know in adding fractions, you got to have a common denominator. So if you had 7 over, or x over 7 plus 2 over 7, you could write it as one fraction of the tops added together over the bottom. Well, we could really do kind of the reverse process, going from one fraction to two fractions. So we're going to put each top term over our denominator, each top term over the denominator, and subtract. Now all we're going to do is simplify our fraction. You'll notice here your y's are going to drop. You have two more z's in the top, so that's why there's a z squared. One more x in the top, that's why there's an x to the first. So we end up with that. And you'll know we don't have to put it over the 1. And then over here, your x's are going to drop. Your y's are going to drop. Or no, your z's will drop. And then your y's, you have one more y on the top. And so then we have this for our answer. Notice, though, that this should be a z squared, since we had a z squared up above. Over here, we're going to go ahead and simplify. You could go ahead and FOIL the first two, FOIL the last two, and then multiply your answers together. But it's going to be easier to use this idea. Right now, we have something squared times something squared, like we have here. This could be written as the two things multiplied together and then squaring your answer. So that's all we're going to do for this one here to make it a little bit easier. So we're going to just put the stuff in the parentheses together and then square the whole thing. Now, what we have in our parentheses are conjugates. When you multiply conjugates together, your inner and your outer terms are going to drop. So we'll multiply the first terms together. Our root x times a root x is a root of x squared, which simplifies down to x. Multiply your outer terms together. It's a negative root xy. Inner terms, it's a positive root xy. Notice they're going to drop. They disappear. They cancel each other out. So we have our x here. Now we're going to do our last terms. A root y times a root y would be just a y, because it would be the square root of y squared. But notice it's a positive root times a negative root, so that's why your answer is negative. Still all squared. Once again, those drop, leaving you with just a minus y after your x. Now you need to go ahead and square this, which means multiplying by itself. So then you would have to FOIL that out, collect your like terms, and you would be done. Well, here you're squaring. You cannot apply your squared to each one on the inside because there's plus or minus in here. If it was multiplication, then you could. All you really want to do basically is kind of a expanded version of FOILing. You multiply it by itself, because that's what squaring means. Now you want to take your x squared times your x squared times your x squared times your 1. Now you got to come back, take the x here times your x squared, your x and your 1. Then you got to come along and take your 1 times your x squared, your 1 times your x, and your 1 times your 1. Then just go ahead and collect your like terms. Here you have a cubed. Here you have your squareds. Here you have your normal x's. You combine all those together that are like terms, and you get this.